Hello, nice to have you here. This video is about an EQ platform with photographic functions, that means tracking in right ascension and declination from TMS-ASTRO. This is the second part. There is a first part where I basically explain how the EQ platform works, how it works, what you have to pay attention to and so on. And there is a third part in which I will show you in a practical way how to mount a 16-inch Dobsonian on this platform and then use it in practice.
Thank you in advance for your patience. I know this is a very long video, but A, there are relatively few videos about EQ platforms, and B, there are practically no videos at all about platforms like this with an ST4 connection. And that's why I decided to do a more in-depth review of the device. You can see here that I have actually already had an evening up observing, and I can say it was a complete success. What I couldn't test was the ST4 functionality, but overall, the stability of the platform, it was just great and a lot of fun. I also calibrated it. The thing was exactly on the same object. Great! There's a separate video in which I'll show the functionality and hopefully a bit of EAA too. Be patient, it will definitely take 2 months until the video is finished. That's why I'm not making a purchase recommendation yet, not until the thing has been fully tested. Personally, if you ask me, I'm convinced that for the price, you can't go wrong with this platform. And if you're not expecting a super high precision device, and perhaps not necessarily as stated here, 30 seconds or 300 seconds, I think that was actually the exposure time, but perhaps stays in the short exposure range of 10, 15, 20, or 30 seconds, then I think this platform is absolutely suitable for that. But as I said, we'll just have to wait and see. My final verdict hasn't been made yet, and it will depend on how the photographic tracking with the ST4 actually works. I'll be doing it with StellarMate, so with iOS and K-stars, not with Nina or an ASI error or anything else, but with StellarMate. I'm really looking forward to it. First of all, thank you very much for taking the time for this video, and as always, clear skies and have fun. So here we see the old Martini platform, as it was attached to the rocker box, rotatable in the middle with the ball bearing. Below is the actual platform. That was also a purchasing decision. It has simply proven itself, and in terms of size, it's practically identical. This is Dieter Martini's old platform, made of wood and with a very simple motor control. I don't think we need to explain much. Well, of course, yes, there's a world of difference. It basically does the same thing. The difference is that it can't do this movement. It's computer controlled, so it's exact and you have to constantly readjust it while you're observing. So that's not so great. Oh, I'm really excited. I'm really curious.
Now I'd like to tell you, why did I buy this platform? How did I come up with it? Well, I've done a lot of research on the internet over the years as I've had the idea for a long time. The Geoparida Eartha doesn't have deck tracking, nor does it have ST4. It was just a normal platform, my first EQ platform. And I've always been a bit keen on a platform that I could track via an ST4 connection with the aim of doing EAA with the Dobsonian telescope. That means taking photographs. But not only that, or during an evening of observation, for example, to quickly show an object on the tablet when doing life stacking, but also to perfect visual observation and track.
There are two variants. The first variant is the old TMS-ASTRO platforms and various others. They only track in right ascension. That means they move the cone, and they also have an ST4 connection to track the movement. If they are properly installed, that is sufficient. But there are also platforms that also track in the declination axis. And for this, it is necessary to be able to move the rocker, so to speak, the plate at the top, up and down in the direction of the declination, from north to south. And this is usually done using a small spindle.
These have existed for a long time. If you type it into Google or the submachine of your choice, you will find, or usually find, you will come across these relatively quickly, the Equatorial platforms. This platform is a mixture of a VNS platform with these vertical segments on the north side and a circular segment platform or construction on the south side with what is essentially a section of a full circle that is slightly tilted. Yes, two things. So a very, very, very expensive. So we're talking about 200 euros for around 3,000 euros. I'd have to look up the price list, but yes, exactly, or even more expensive. And what bothered me about it too was that it has this deck tracking, right? And it also has an ST4 connection. What bothered me was that the circular segments were welded in place and you couldn't replace them. That was a deal breaker. No, so you don't buy it or you need it yourself. Then, a few years ago, this TEP came onto the market from Hungary, and I thought it was cool, but I think it weighs 25 or 28 kilograms, so it's incredibly big, and has corresponding tracking in the declination axis. You can see the motor here at the front. It's very unwieldy, very heavy, and has the same construction as the ERTA, which I sold back then. You can see here that it's at 30 degrees, right? And if you're like us at our latitude at 50 degrees north, then the thing moves here, and so this southern bearing, and the whole thing is a complete nod. It wags its tail up and down here at the front. It's an absolute disaster. That's why it was out of the question for me, and the price was steep. I think he wanted more than 2,500 euros for it. Of course, it's an incredibly complex construction, so it was out of the question for me. I kept searching, and by chance, I came across the company TMS-ASTRO. First, I saw the old version, this wooden platform, and then I went to the website and saw, aha, there's something new.
An EQ platform for astrophotography with SD4 port, that's exactly what you want. He also has two little pictures here where he shows that he tracked for 300 seconds and then for 600 seconds. I'm not pixel peeping. You can take a look for yourself if you want. The prices were just here. I had a look. It costs 520 euros. But those are exactly the prices for the old platform. I didn't find anything here. Discontinued, they're no longer available either. So it's now completely switched to this new form. Then I looked further and saw that I can buy the whole thing from Teleskop-Express. So with a guarantee from a manufacturer I know well and from whom I, or a distributor, buy a lot, or pretty much everything. Well, and then I saw the price and thought, okay, you can't go wrong with this design. I pressed the buy button, slept on it, and then I actually ordered it. You can see that it's currently no longer available. Thomas Horvath from Hungary, who builds these platforms, has to build them again. You can look up how it's done on the internet, and above all, what fascinated me is here a video about the controller. It has a push button here, and through it you can access a platform, or it has an automatic function, and then I have 10 seconds to pause it, and it goes back again. I thought that was great. The second story I really liked was that it has a polar alignment feature. That's nothing other than the thing swinging back and forth, giving you the opportunity to properly align the platform. Okay, that was clear to me. I'll buy the thing, and yeah, now let's take a look at it. The platform I ordered here from TMS-ASTRO, I ordered it through Teleskop service, but you can also buy it directly from the dealer. You can see it was well packaged, excellent. There are a few accessories that I'll go into in more detail later. It's about 60 centimeters long and about 50 centimeters wide. Here you can see the corresponding altitude wheels, and the whole thing is well built, sturdily riveted from aluminum. There's a really interesting accessory here, and I first had to find out what it was actually for. Unfortunately, there weren't any instructions included, but that's not a big deal, I'd just say. All in all, we'll look at the individual aspects of the platform. These are just a few pictures to show you or to warm you up a bit and give you an idea of what you can expect from this video. After unpacking, the device comes upside down, so to speak, and then you screw in the feet. You can see the motor for the deck axle and the mechanics here at the back. That gives a very good impression of the mechanics. The support for the elevation wheels is very well designed. The whole thing is extremely light. You can see that it really only weighs 8 kilograms, but it is still very stable. You can already see during assembly that you can easily access the wheels and the settings from here. And of course, if you want to adjust it when the instrument is on, but also the lock nut. He did a great job. You can get to it easily from all sides at the front. He solved it the same thing at the back, right? You can get to the back really well too. That is important for the settings. They are 3D printed parts. That means, take a look. If it ever breaks, you can always make a 3D print yourself. This is an intelligent sealed lead-acid battery charger, and it is designed to adopt advanced 3-step charging. So it is a lead-acid battery charger with an IC, so it is a relatively intelligent lead-acid battery charger. We have already discussed this charger. It is included. It is an IC battery charger, and it discharges the battery very quickly. So you can always leave it on if you have the thing at home, and then you just plug it in here on the other side of the device. I actually find that quite practical. I'll take the top off. Be a bit careful. There is a plug here, and that is the actual power supply, right? That means you can really connect any 12-volt battery to this. But first, the battery is unplugged when you use it for the first time, which of course makes sense because otherwise it would discharge. So we have the first accident. So it comes off really easily. You really have to be careful there.
One more thing, because you just saw a bit of it, I pulled on it again here, and that's dangerous, of course, because you put tension on these connectors very quickly. They're normal XJ something connectors, though, if you have a 3D printed board. But I simply went and put some strain relief on it with gaffer tape, and I also resoldered the cable. Tomasz was kind enough to simply tell me which cables belong where. It took 2 minutes to fix it, so strain relief is important. These are the standard stepper motors. You can also see that on the packaging, by the way. That also means that these are things you can always buy again if something breaks. These are standard parts. Everything is standard on the entire platform. It's riveted. It looks like a completely normal aluminum rectangular tube, right? Quotation marks, with 3D tubing at the end. So everything here is easily repairable. So if you have a 10C milling machine or know someone who does, you can rebuild something like this. Of course, it's possible, not broken, but it could be. I think it's really great how this has been solved here. I like it. Another special feature, and you can see it when the platform is still turned over, they used really solid pieces of aluminum. In terms of thickness, I'd say it's a good centimeter or at least 8 millimeters thick. I just think it's a good idea not to skimp here. Unfortunately, I've seen far too many platforms that aren't that good. And you can see it here, maybe. It's covered with duct tape. Very simple, straightforward duct tape so that the motor has grip here. A really ingenious, simple solution. I'm excited to see how it works in practice. But this also gives us the opportunity to take another look at the whole thing from above. Yes, you can see a few marks, tracks, marks that I see here too. Well, that won't be avoidable in the long run. Yeah, and here is the motor unit again. And no, it's wobbly, it just has a bit of play. That's how it is. It's not a big deal. It's not tragic. Okay, so that's been bothering me. I had to look it up online again. On Stepper Online, you can find these planetary gears, and the one installed here is a 27-to-1 planetary gear. The simple model costs around 30 euros. And here we have these slightly more precise versions, which you can also find on AliExpress, right? And the first thing that stands out is that it's 30-to-1 and not 27-to-1. That would actually be the industry standard. You have 10-to-1, 20-to-1, Z, 40-to-1, 50-to-1, 100-to-1, so more whole numbers. That would be easier to replace than this 127. So point 1, point 2 is that it has a much higher quality, it just costs twice as much, but in my opinion, for a mount costing 1,300 euros, the 30 euros is no longer worth it, and then you should have gone for something more precise. I'll even go a step further, but unfortunately it's a bit more expensive. These gears are now available on the Chinese website, AliExpress or wherever, as harmonic drive, and I think that's the future. I've seen them before. The gear alone costs 50 or 60 euros, but if you buy them regularly, they can cost up to 180 euros. So we're still a bit away from that, and we're probably just using a sledgehammer to crack a nut, but I think it's cool to have a backlash-free drive, and why shouldn't we? I think at least a high-precision gear belongs in the Axis. It wobbles, it has a bit of play, that's the way it is. It's not a big deal, it's not tragic. The battery, the cabling, if we take that off, you have to be a bit careful. Here you can see the stop for the deck axle, and you can also see here that it seems to be a different gearbox than this one. I have to take a closer look at that.
It's the same motor, but a different gearbox, probably a different ratio. Yes, overall, it's completely fine. And as I said, very solidly built. I've said that before. So you don't have to worry about that.
The TMS-ASTRO platform, or many platforms have, where the manufacturers offer different circular segments. You can tilt the platform a bit, that means bring the south bearing down or the north bearing up, or visor-size segments, which I have here. I live in Germany, near Mannheim or in Ludwigshafen, so Mannheim, Heidelberg. This is pretty much on the edge of what the manufacturer intended here. They created a flat segment. It's suitable for a northern latitude of 45 to 50 degrees, then a bit further south from 40 to 45 degrees and even lower, and from 55 to 60 degrees. So you're completely equipped with that here in Europe. It probably won't be possible much further south, and I don't know if it's possible farther north, but I think it's certainly conceivable if you talk to the manufacturer. I can't say exactly. The circular segments are interchangeable. There are 2 screws here, and then you can remove the old one and attach the new one. So it's relatively straightforward, and that's the advantage of the VNS platform. So after a while, you can see now, after various tests, the duct tape is already pretty damaged. Incidentally, it's also emphasized in the instructions that this is a maintenance task. And I've done quite a bit of fiddling around with it in the workshop, I must say. I've already tested the whole thing and tried it live. So the wear and tear is relatively okay. Time will tell, but I don't see any major problems there. So it's time to turn the thing around. I've switched to wide angle. Sorry, I have to do this with one hand. I don't have a tripod here yet. And let's turn the thing around. And there it is. Yes, that's how I imagined it. Up here in the front, you can see the mount here. That's great. This is a rotating bearing. There's the bearing journal. It has to go in there, of course. And because it's made so that it can move up and down, it's a small cylinder. This gives it the play it needs. That big. Now, of course, comes the main part, the journal. A bit silly with one hand, but okay, sorry about the wobbling. So, the journal. It has to go in here now. I'll take a look at it with the camera because I can't see it like that.
I also think that you should really do that during transport. Now it's in, it's slipped in, there's noticeably no play. Makes a very good impression. You can see another thing. You have to be extremely careful here. The thing can tilt very easily. Well, I think for transport or something like that, we might need another one of these, not just this one. I'll demonstrate a second one or think of something, print something, so that this can't accidentally slip out of place. If the part is standing upright, it's not a problem, but this seems to be a bit of an Achilles heel to me. This is probably the mount for the spindle again. I've now stood the part upright, so everything underneath is flat and poses no mystery. I did this because I wanted to take a closer look at the mechanics or what goes on down here in general. So you can see the emergency stop switch here. It's not a mystery. We can argue about that. Would we perhaps need to put a cover on it? Yes, we could, but it's not absolutely necessary, right? Here is the emergency stop. If the thing comes down too far, then we have the stepper motor with a gear. A planetary gear, I have to check what kind that is. Well, in terms of quality, there is a difference in quality. And now here's the thing. Now let's take a look at this mechanism. That's mega enough. Now I understand it too. The belt goes in here, and it has pulleys here. I assume it's 3D printed. I don't know if you can... Yes, now you can see it better. Those are pulleys. That means the belt is rotated and then goes onto a large gear here in the hollow part, and you can rotate that too. You can see how it works. And then this shaft rotates and moves the thing up and down. So how cool is that? That's a really intelligent design. I hardly notice any backslash here. You can maybe see a tiny bit, but that doesn't play any role at all with this type of construction. Zero. So it's made very simply and straightforward and seems very robust to me. I don't know how he stored it in there, but you can take a look at it if you take it off at the front. Just a chance, so you can see a short inset.
After using the part now and reading the manual, I know that this is the calibration switch when the mount is switched on. We'll come back to that later. Then we have the mechanics for this rocker up here. Yes, he used standard hinges there too. Bought and used decent stuff. So next component. Let's take a look at the drive. It all looks really, really neat. Everything is 10C milled, decent components, decent couplers. That's how I would build it myself. Exactly the same on the other side. Excellent workmanship. Great, yes, also the connection, everything is stable and sensibly mechanically coupled. So as long as the telescope isn't on top, let's take another look at the mechanics. As I said, extremely robust. So my colleague has this duct tape underneath here, right? You've already seen that. And it's resting on a really nicely grooved part here. So I don't think anything will slip through there. Nothing should. So from the backslash, I can already see a tiny bit of backslash. But that doesn't matter. I know it from other platforms too, like the G-Optic ETA. That's because of the planetary gears of these stepper motors. They're not 100% backslash free. Yeah, I don't know. Let's see if you can see that.
Yes, you can see it quite clearly. It's not from the mechanics, it's from the stepper. But that's not a problem. It's really not a problem. When the DOPS is on it, it always has, how should I say, a slight pull in one direction. And a backlash-free mechanism like that, you could perhaps achieve that with a harmonic drive, which is available now or maybe in a few years. Then you can replace it, and then you have absolutely backlash-free drives. So then it has a very, very large compass here. Great, you need that. And on the other side, a large spirit level. You also need that for leveling. Cables neatly laid, everything very neatly laid. No bare ends anywhere. Very nice. I really like it. It's well done.
It's an M3 hole, so several. 1, 2, 3, 4, 5. Yes, of course, a holder like that slides in nicely, which you need to put your dope on here. I'd like to show you briefly what it's like when you trigger the controller. Please just ignore what's here and the fact that there's a bit of something stuck to it. So we'll look at the controller separately. When you switch it on, that's what we're talking about here. What happens here? We're in photographic mode. The dip switch is at the top, the 6th, the last one. I switch the thing on, and then two things happen. A, the rocker here at the front, so the motor here at the front will move down to the switch. When it gets there, it will move back up, and at the same time, the platform at the back will go into the home position. Let's take a look now. So I press here. Nothing happens in the RAE at the back, but here you can see the thing starting to rotate. Yes, that means it's moving down here now. I hope you can see that. Yes, sir. So it's now approaching the switch, and the moment it reaches the off switch below, which is why I'm going back now because that's about to happen, you can see it moving into the home position. The nice thing is, it doesn't have a switch as such, but rather an electronic switch, a proximity sensor. I don't know if you can see it very clearly here at this point. Yes, and as soon as you touch it with a piece of metal, it goes into stop. And then the thing stops flashing and goes back to normal mode. It just beeped and heard it, and now it's in tracking mode, so to speak. It's a really great thing. I'm really mega excited to see how this thing performs in practice. The controller has a second function. You can use it to align the EQ platform. Or let's put it this way. It's an aid for aligning the EQ platform. So how does that work? It's relatively simple. You turn on the controller while holding down the button, then the platform moves to its end position.
So imagine the Dobson is now standing on it. Then I aim at Polaris. Once I've done that and have the NCP, or the current time in center, I press here and the rocker goes into its end position. So what does that mean? If I now look at the NCP again with the Finder, or you can use Nina or any other program that offers a polar finder function, then I can adjust it accordingly. Once I've done that again, I go back and so on and so forth. I do this until the platform is leveled, so to speak. When I'm done with that, I simply switch it off and on again, and then the usual process begins. The declination axis levels itself out again at front, and when the thing reaches the bottom of the switch, the light here stops flashing and the whole thing moves into the R position. It doesn't have to be that way, because it's already there and starts tracking straight away. Let's do a few more seconds so you can see it. When it stops flashing, the platform starts tracking. It should actually happen right away, but when it doesn't happen, it comes up wrong. Yes, that's quite interesting. No, yes, exactly, that's it. And now it starts. 12 seconds can be quite long, and now we start tracking. I'll do it now. Unfortunately, I can't simulate it. So let's assume the platform would move over here now, right? Little by little. Now it manually moves over here, and then it arrives here at some point. There, it's finished, and now it starts flashing again. It's basically this automatic mode. I'm not sure if it reports an error. No, it's not quite finished yet. Then it usually waits another few seconds. And then after these 12 seconds, which we've just seen, which were relatively long, it should start again in the money, and then it moves back to the starting position.
You have the option to interrupt it if you don't want it to. That's why it takes 12 seconds, and I actually think that's a good thing. Yes, it drives all the way over, and when it gets there, as long as it's flashing, it works. It's been a while, and then it carries on again. It's a great function. I've already had an evening of observation. It works perfectly. If you want to know exactly how the signaling works, I've explained it in detail in another video. That's why I'll stop here, otherwise the video will be too long. One more word about the transport concept. You remember we talked a bit about this pin coming loose here? I have 3 corrugated irons, one here at the front. It goes across the entire width. And then I have one here in the middle that connects the 2 components together, the cradle and the actual eco-platform. Then I have one here and one here on the side so that the segments are here. Underneath each segment, as was delivered by default, is a small piece of this film, a slightly thicker film. So nothing can really go wrong there. So now it's actually ready for use. Now you just have to figure out how to mount the telescope. Then I'll try to summarize the most important points in just under 5 minutes, including the general specifications. The price of 1,300 euros is fully justified in my opinion. The device comes from Hungary, so from Europe, therefore the price is a European-German price. I purchased it through TS, Teleskop-Express, telescope service, and compared to other platforms, it's absolutely fine. The weight of 9 kilograms is great. That's a nice sweet spot between significantly resilient, yes, and lightweight. The material is aluminum, and the components used here are all perfectly stable, solid, yet still lightweight, like these aluminum tubes. That means these 80 by 20 square tubes. This is also due to the solid and intelligent construction and the large strong aluminum sheets, 10mm sheets, 8mm beams, which they use for the segments, and according to the manufacturer, it's suitable up to 12 inches, that's 12 dowels, but they also say it can be larger if necessary. And as you can see, with a lightweight nozzle like mine, and especially one that's well balanced and easy to move, it's definitely suitable for more. Then there's the drive. The drive is in the reaction axis, that means on the segments from the stepless planetary gear via a roller. The roller is cushioned slightly by duct tape or just given more grip. It has to be said that the planetary gear has a slight backlash. I know these motors, it's normal, and visually it's not critical at all, so I didn't notice anything. You just have to test it photographically, especially when the thing oscillates. The Dobsonian usually always has the tendency to push in one direction, and so I actually assume it's not good, but they could have chosen a better quality planetary gear. They do exist. The drive for the declination is also a stepper in planetary gear. The planetary gear is better here. You can clearly feel and notice it. The drive is via a spindle, which in turn is driven by a belt. So, very good. Apart from that, the ease of repair is also good. So, overall, you can say that they are only standard parts, and therefore the thing is generally easy to repair. You never know what will happen. I've experienced all sorts of things with it, and so it's very future-proof. The design, the operation, it's a well-thought-out one-button operation. It's completely straightforward. It's child's play, and the automatic operation is simply great at night. The cable management is neat and tidy. It's okay for operation, but not so good for maintenance, especially when you take the top and bottom sections apart. And there's a risk of tearing out cables. That's why you have to provide strain relief yourself. I think the manufacturer could have done a bit better with that, and I'm sure they will. It's not a big deal. I solved this with duct, and that actually loses a small point. But it's easy to do, and if something comes loose, it's easy to repair. So not a huge point deduction. About the manufacturer. The manufacturer is TMS-ASTRO from Hungary. His name is Thomas Horvath, and he has a website. Distribution is obviously handled by him, although you can't currently access this platform on the website or via TS telescope service, or maybe it's available somewhere else. I haven't seen it yet. Yes, future-proofing. The manufacturer has been around for over 5 years, and you can clearly see the iteration of devices and the constant improvement of the controller, which is why it's a clear number 1. It's not at all a given.
Unfortunately, there are a lot of manufacturers that arrive on the market and then disappear very quickly, as we saw with the TAB, or that don't develop at all, as we saw with the GeoPic. I could tell you other things about that, but I'll leave that aside for now. Yes, contact with the manufacturer. Great. I did it via email.
They also have a Facebook page and I think Instagram too, but I don't know if they look at it. In any case, they responded to my inquiry relatively quickly, about 2 days or so, so completely normal. Over the weekend, I think it was uncomplicated too. Very nice contact. Yes, now for the test results. I noticed differences visually and photographically. I haven't done any photography yet, but I can say that the visual test is excellent. So I have the object not a whole hour because you don't observe for a whole hour, but about a quarter of an hour in there, and you notice that high magnification whether the thing is running out or not, period. Exactly. However, a restriction only if you look at it properly. And I did that because it's relatively easy with this classification aid, I would say, and also the instructions that I described in the first part of the video. Stability, yes, you've seen the pictures. There's a 40-kilogram Dobsonian on it and 16-inch Dobson. I have to say, though, it's a lightweight Dobson, and B, it's well balanced. So you have to say, I would say that's important, right? It runs easily, it's well balanced, and if it's in some kind of clunky giant device with a very high center of gravity, then I would be careful with the platform. And TAM Shortword also states quite clearly that the device is approved for use with up to a 12-inch Dobson, and I wouldn't really go any further than that. As I said, more on the practical tests and photographic text in part 3. So it gets an overall grade of 1, which I can fully support based on my experiences so far. One evening of observation, well, rather yesterday evening, I added another. But I'm always cautious at first, so more on that in part 2 of the video, which will also cover the photographic function. That means the tracking functionality with ST4. For now, thank you very much for your patience and interest. I wish you clear skies and lots of fun with whatever you're doing or planning.